Hi students, let's go through fifth part of first problem from exercise 1.1. Relation R in a set A of human beings. So set A is a set of human beings in a town at a particular time, in a town. So what is the relation? X and Y work at the same place. X and Y work at the same place. And what are X and Y here? They are human beings, right? So you have set A, which is set of human beings, right? And the relation is all these human beings work at the same place. They work at the same place, right? So that is what we'll have to figure out if it's symmetric, transitive and reflexive. Now, for reflexive, what should it be? The same element, x comma x. If x comma x belongs to R, for all, right? For all x that belongs to A, right? For every element in this set A, x comma x should belong to R, right? Now, for all human beings in this set, all the human beings, they should work in the same locality, right? So x comma x belongs to R because x and x work at the same place, right? X and x can work at the same place. Therefore, this relation is reflexive. Symmetric. If xy belong to R, what is the condition? If xy belongs to R, and yx belongs to R, then you can call it a symmetric. The reverse. If xy belongs to R and yx belongs to R, then you can call it a symmetric. Now, it's simple, right? Let's take this example. You have x and y. X and y is Ram and Sham, right? So if Ram and Sham work in the same locality, they work in same locality. Ram and Sham work in same locality. So for symmetric, it should be y comma x. That is Sham and Ram. I am reversing it. Sham and Ram work in same locality. Does it matter if I change the positions? So if Ram and Sham work in same locality, we can also say that Sham and Ram work in the same locality, right? I can reverse the names. It doesn't make any difference, right? So this condition is true. I can say since xy belongs to R and yx belongs to R, R is symmetric. You can take this example and prove it. Now for transitive. For transitive, what is the condition? If xy belongs to R and yz belongs to R, then xz should belong to R. The first element and fourth element should belong to R. Now we'll take an example. If Ram and Sham work in Bangalore, same locality, right? Say this is x, this is y. If x and y work in Bangalore, then I should take y and z. Sham and z, let z be Sita. If y and z work in Bangalore, say y and z also work in Bangalore, then can I say Ram and Sita, that is x and z, right? X and z. Can I say Ram and Sita work in Bangalore? Correct, right? If Ram and Sham work in Bangalore and Sham and Sita work in Bangalore, it means all three work in Bangalore, right? All three work in Bangalore. So it also means that X and Z, that is Ram and Sita, work in Bangalore. Therefore, this is transitive. This is just an example to explain, but it's enough if you say if xy belongs to R and yz belongs to R, then xz belongs to R. Or you can write it as if x and y work at same place and y and z work at same place, then it means that x and z also work at the same place. Therefore, R is transitive, right? In both of these forms you can write. This is just an example. The next one. Here the relation is given as x and y live in the same locality. Exactly the problem is same, right? Here it was working in the same locality. Here it is living in the same locality. Same thing. So R is reflexive because x comma x, right? Right? The same person can live in the same locality, right? So x comma x belongs to R. Symmetric. So if Ram and Sham live in MG Road, Sham and Ram live in MG Road. This reverse is also true. Ram and Sham live in MG Road. I can reverse it. Sham and Ram live in MG Road, right? So if x and y live in MG Road, y and x also live in MG Road. Therefore, this is symmetric. Now transitive. This is also transitive, same like the earlier example. xy belongs to R and yz belongs to R. It indicates that xz belongs to R. That is, you should write it like this, similar to this. If x and y live in the same place and y and z live, in that example it will be live in the same place, then x and z live in the same place. Now, let's look at this particular relation. X is exactly 7 centimeter taller than y. X is exactly 7 centimeter taller than y. This is very important. 7 centimeter. Right? This makes a difference, big difference. Now, let's see if this is reflexive. So, x comma x should belong to R. Right? That's the condition. X comma x should belong to R. That is, x should be 7 centimeter taller than x. Right? Instead of y, I'll have x for reflexive. X is exactly 7 centimeter taller than x. That's what it means. So instead of y, I'm putting x. X comma x. So x is exactly 7 centimeter taller than x. Can I be taller to myself? No, right? I can't be taller to myself. Right? Therefore, this is not reflexive. Therefore, I am telling x comma x does not belong to R, and therefore R is not reflexive. You can write it like this. Next, symmetric. For symmetric, if x is 7 centimeter taller than y, if x is 7 centimeter taller than y, then for symmetric I should reverse it. Right? It should become y is taller than x. If x is 7 centimeter, if x is 7 centimeter taller than y, is y 7 centimeter taller than x? That's not possible. That's not possible, right? If x is 7 centimeter taller than y, can y be taller? No, y will be shorter, right? It will not be taller. Therefore, this is not symmetric. So you should write it as xy belongs to R, but yx does not belong to R, right? You can write it as does not imply. Xy belongs to R does not mean that yx belongs to R. Does not mean. This is does not imply. Does not imply. Right? I can write it like this. Xy belongs to R. It does not imply that yx belongs to R. Therefore, R is not symmetric. R is not symmetric. I can also write this as R is not symmetric because x is 7 centimeter taller than y does not mean that y is 7 centimeter taller than x. Now let's look at the transitive case. Here, you should take x, y, z and x, z. This is the combination. If x is 7 centimeter taller than y and if y is 7 centimeter taller than z, it does not mean that x is 7 centimeter taller than z. It's like this. Now let's take Ram, Sham and Sita, right? Let's take 3 people here. So Ram is 7 centimeter taller than Sham. Ram is 7 centimeter taller than Sham. And Sham is 7 centimeter taller than Sita. Right? Now does it mean Ram is 7 centimeter taller than Sita? No. Ram will be 14 centimeter. 14. 7 centimeter taller than Sham. And Sham is 7 centimeter taller than Sita. So it's going to be 14 centimeter. 14 centimeter. It's not going to be 7 centimeter. Therefore, it's not transitive. Because of this number, it's not transitive. If it was simply, if 7 centimeter was not there, if it was simply taller, right? Instead of, in the question, if 7 centimeter was not there, assume in the question, if 7 centimeter was not there, then the answer would be completely different. If x is taller than y and y is taller than z, that means x is taller than z, right? If Ram is taller than Sham and Sham is taller than Sita, it means Ram is taller than Sita, right? Ram is taller than Sita. So in this case, it becomes transitive. So the 7 centimeter is what is making a difference in the question. Since there is 7 centimeter, this is becoming not transitive. If it was simply taller without any number, then it would have been transitive. Now, in this case, it is not transitive. So this relation is neither reflexive, nor symmetric, nor transitive, right? Not reflexive, not transitive, and not symmetric. None of them. Now let's take this example. Your relation is x is a y for y. Very simple. right? If X is a wife of Y, Y becomes the husband of X, right? Now, let's take reflexive case. Here, instead of Y, I should put X, right? Can X be a wife of X? No, X cannot be a wife of X. So, it's not reflexive. So, it's not reflexive because X cannot be wife of X. Therefore, X comma X does not belong to R because X cannot be wife of X. So, R is not reflexive. Now, symmetric. In symmetric, what should happen? X and Y, if X is a wife of Y, then is Y the wife of X? You have to reverse it, right? If X is the wife of Y, is Y the wife of X? No, that's not true. If X is wife of Y, then Y is husband of X. It's husband of X. So this is not true. Therefore, it's not symmetric. So you should write it this way. It's not symmetric because if X is wife of Y, does not mean or does not imply that Y is a wife of X, right? Or you can say XY belongs to R does not imply that YX belongs to R. Now, transitive. If X is a wife of Y, what is the next condition? Y is wife of Z. Can it be possible? If X is wife of Y, can Y be wife of Z? It's not at all possible, right? If Sita, for example, if Sita is wife of Ram, can Ram be wife of somebody? It's not possible, right? No, Ram cannot be wife at all. Ram can only be husband, right? Ram can only be husband. So in this case, I can't even take the second case. The second case does not exist. I cannot prove because the second case, that is YZ case, does not exist here, right? Therefore, this becomes transitive, right? Because I cannot prove that it is not transitive. I cannot verify at all because this YZ combination is not there. Therefore, R is transitive here. Now let's take this example. X is father of Y, similar to the earlier problem itself. For reflexive, I'll replace Y with X, right? Y with X. So can X be a father of X? Can X be a father of himself? No, right? It's not possible at all. Therefore, it's not reflexive. Symmetric. If X is a father of Y, then is Y a father of X? It cannot be reversed, right? Right? It's not possible. So, I can say XY belongs to R does not imply that YX belongs to R. Therefore, R is not symmetric. Transitive. Same thing. It will not be transitive because if X is a father of Y, X is a father of Y and Y is a father of Z, then can I say X is father of Z? That's not possible, right? If X is father of Y and Y is father of somebody else, how can X be father of Z? How can X be father of Z? That's not possible. So, it's not transitive. See, there is a difference between the earlier problem and this problem. There, the second case, Y is a father of Z. This is valid here. Y can become a father of Z. So, this condition exists. Condition exists. In the earlier case, this second condition was not valid at all, right? Y becoming a wife of Z, that second condition is not at all existing. It's not valid. That's why in the earlier case it was transitive. In this case it is transitive, but in this case it is not transitive. So with this, we've come to the end of this particular topic. We will solve some more problems in the next video. Thanks for watching. If you like this video, do press a like and share it. Thank you.